Welcome to another Mathnificent Conversation featuring adding and subtracting rational expressions. It's your nerdy math bestie Lex. Grab your pencils and let's go. We're going to cover a few basics before we get started. First, I just want you to understand a rational expression is just a fraction with variables. You don't have to think about it any other way than this is a fraction, just like any other fraction. It just has a variable in the denominator. Rational expressions follow the same rules as fractions. So if we have a set of rules for adding and subtracting fractions, we follow the same rule when we're adding and subtracting rational expressions. When we're simplifying a rational expression, all we're doing is factoring it, just like we factor fractions to simplify. So again, all we're going to do is add or subtract the numerators, keep the denominator the same. All right, let's get started. We've got 1 over x plus 8 plus 3 over x plus 8. Remember, all this means is we have something split into equal pieces that are this arbitrary x plus 8 size. We don't know what that is. What we do know is we have one of them and we're going to add 3 of them to the other. So we now know when we're adding or subtracting rational expressions, we just add the numerators, keep the denominator the same. So this is 4 over x plus 8. X plus 8 is a prime. 4 is not, but x plus 8 will not simplify any further. So 4 over x plus 8 is our final answer. Now we're going to add 2x over x plus 5 plus 10 over x plus 5. Remember, the x plus 5 is just our like term, so we're adding up equal parts that are the size x plus 5. And we have 2x of some and 10 of some. So we add straight across. Now we know we have 2x plus 10 of the x plus 5 pieces. Okay, we always check, can we factor the top? And if you're not comfortable with factoring, please get comfortable with factoring. There are plenty of factoring videos in the library. So 2 and 10 are both divisible by 2, so I can factor a 2 out. 2x divided by 2 is x, and 10 divided by 2 is 5, all over x plus 5. You're going to want to get comfortable simplifying. If you are in a course that's Algebra 2 or above, 9 times out of 10, all of the questions you're asked, or most of the questions, will require you to simplify after you compute. So we know this is equivalent to saying 2 over 1 times x plus 5 over x plus 5. Something divided by itself is 1. So now we're just left with 2. With rational expressions, because we cannot divide by 0, and any fractions, that rule never changes. You cannot divide by 0. You have to denote that now that we no longer see the x plus 5, you have to say that x cannot equal negative 5, because negative 5 would cause the denominator to equal 0, and that will never ever exist in the domain of a rational expression. X squared divided by x plus 1 minus 1 over x plus 1. We know subtraction follows the same rules as addition, so we subtract the numerator straight across. We get x squared minus 1 all over x plus 1. We always check, can we factor? X squared minus 1 is a difference of 2 squares. There's a difference of two squares video if you're unfamiliar. It factors into x minus 1, x plus 1 is something you should be able to recognize immediately if you're in high school. Okay, so now we have x minus 1 x plus 1 all over x plus 1. Because x plus 1 is at the top and x plus 1 is at the bottom, I have a factor divided by itself. That simplifies to 1, and I'm left with x minus 1. And we know we have to say x cannot equal negative 1 because negative 1 would cause the denominator to equal 0. X squared all over x squared plus 2x minus 15 minus 9 over x squared plus 2x minus 15. Now, even though the denominator looks a little complicated, just remember it's some equal parts. That's all you need to keep in your head. And we're subtracting from it something with the same sized equal parts, which means we can go ahead and subtract straight across and keep the denominator the same. Okay, we don't like to leave anything not simplified. The top is a difference of two squares, x minus 3, x plus 3. The bottom is a quadratic whose leading coefficient is 1. So that means we need factors of negative 15 that add to positive 2. So that's going to be 5 and negative 3. So we get x minus 3, x plus 5. X minus 3 is a factor of the top. X minus 3 is a factor of the bottom. So that simplifies to 1. So we're left with x plus 3 over x plus 5. Remembering we have to remind, because it's no longer visible, that x cannot equal positive 3, because positive 3 would have caused the denominator to equal 0. Okay, we're adding two fractions, same denominator, which means we're just adding up some things that have the same sized equal parts, which means we can just add the numerator straight across. 9x plus 4 plus 2x squared all over x squared minus 16. The top is not arranged in standard form, so we're going to go 2x squared plus 9x plus 4 all over x squared minus 16. Both of these are quadratics, so both need to check, can we factor them? The top is a quadratic where a is bigger than 1. So I'm going to go off to the side. A times c is 2 times 4, which is 8. Two numbers that multiply to 8 but add to 9 will be 8 and 1. Divide by a. This simplifies to 4 over 1. And then remember, we go bottom to top. There's a video on this if you aren't sure how to factor when a is greater than 1. So this is x plus 4, and this is 2x plus 1. So we have x plus 4 times 2x plus 1. The bottom is a difference of two squares, x minus 4, x plus 4. My numerator has a factor that's x plus 4. My denominator has a factor that's x plus 4. So those two simplify to 1. So we're left with 2x plus 1, which is now prime, x minus 4, which is now prime. And because it's now invisible, we remind everyone x cannot equal negative 4. We reached our last example, x squared over x minus 1 minus negative 2x plus 3 over x minus 1. What's important? The denominators are the same, so we're dealing with the same sized equal parts, so we can subtract straight across. In all areas of math, subtraction can be a little bit tricky when you have multiple things to the right of it. So I always rewrite, if I'm subtracting, anything to the right in parentheses, so I remember that that negative needs to be distributed. So now this negative has to distribute to both terms. So we have x squared plus 2x minus 3 all over x minus 1. The numerators are quadratic, so a is equal to 1, so we can factor it. Two numbers that multiply to negative 3 but add to positive 2, it's going to be 3 and negative 1. So x plus 3, x minus 1 all over x minus 1. The numerator has a factor x minus 1. The denominator has a factor x minus 1. So those simplify to 1. So we're left with x plus 3. And we have to remind everyone x cannot equal 1. I hope this was helpful as a starter point in adding and subtracting rational expressions with the same denominator. The fractions and rational expressions series will be long. I will do a lot of explanations. Remember, you're magnificent, you're brilliant. I'll see you in the next video.